Welcome to this overview of NX mechanical routing. NX provides the common user interface and customization tools for process-specific routing capabilities. Companies can enhance NX with their own standard parts, design rules and system changes. Routing systems supply the user with design rules and example libraries for piping, tubing and steel section. Routed system models are fully associative to NX assemblies to facilitate rapid modelling and design changes. Mechanical routing features accelerated path creation, intelligent part placement, parametric part selection, customizable part libraries, bill of materials automation and flexible application attributes. Part 1 of the presentation will show NX routing being used to route a 20mm air pipe down the side of a frame. This presentation is designed to show the various features of NX routing and some of the methodologies used to complete a route. The pipe will be routed from air tanks in the rear to a position in front of the frame. U-clamps have been placed in the assembly to locate the pipe. The pipe geometry is to be placed in a separate component file, which is to be set as the work part. When initiating the routing application, various preferences can be set before the first route is placed. Setting the discipline defines the default libraries to be used in the session. In this case, the discipline is piping. The default stock can be selected as initial preference. A default stock of NPS 20 is chosen. A default style of detail will display the inner and outer diameters of the pipe. The default size for pipe bends is set to a ratio of twice the pipe diameter. Two gland nuts are to be placed in the tanks. As routing part families, they are selected by the pipe size. In the reuse library, the selected components are placed on the tank's attachment ports. These ports allow for automated placement of pipes and fittings both in location and orientation. The heel path commander connects the route centerline with 2 points. The start and end locations are first picked. The direction of transition can then be chosen. This route will first travel on the x-axis, then the y-axis, then the z-axis between the start and end points. The order of these transition directions can be changed. The end point is modified to be 300mm back from the clamp. The white line represents the center line of the pipe. The Create Linear Path command places pipe segments directly between 2 points. The port from the gland nut is selected. The route segment is directed to transition parallel to the port and attach itself to the previous route. The geometry representing the pipe stock can be added while routing segments or on completion. Placing the preferred stock will add the stock selected in the initial preferences. The selection intent of routing will select all routing segments contained within a single route and add the stock. Assign corner will add the default corner treatment to the complete route. Fittings are added from the reuse library. A T-fitting is selected, matching the default stock size. Placing the T on the route will automatically locate and orientate the fitting, trimming the pipe stock to suit. The air tanks are located by assembly constraints. Using these constraints to move a component will update the route. New constraints can be added to the route segments to apply design intent. Here a dimension is added to maintain the distance of 300 mm between the segment from the tank to the bend. When the tank is repositioned, the vertical section of the pipe now moves to maintain the design intent. Moving to the front of the frame, additional routing segments will be added. In the Create Path command, the defaults for stock and corner treatments will be now added as the route segments are placed. The first point selected is the port in the clamp. The mode is then changed from specified points to axis parallel. The next ports are selected and the system calculates the intersection points. Stock and corner treatments are added. Another method to route the same pipe segments is to dynamically sketch the route. As before, the port in the first clamp is selected, then the mode changed to dynamic axis and the segments added. Assembly constraints such as parallel and align are added to edit the placement of the segments. Straight segments are easily added between points in the assembly. Additional segments are added from the straight segments. Segments can be selected and their lengths altered. Heel path is then used to connect the remaining segments, adding the required offsets. This method of routing uses linear path to place the straight sections of pipe and then heel path to connect those sections together. Design rules will constantly check for violations. Here a segment is being reported as less than the allowed length. Other default rules include pipe and fitting incompatibility and invalid bend radii. Fittings can be added to the ends or interior of pipe sections. Depending on the type of fitting, the pipe will be divided or trimmed. To locate and place a fitting within the pipe, I first subdivide the route segments into two pieces. From the reuse library, the fitting is chosen based on the default pipe size. As with the T-piece added earlier, the fitting is located and the pipe divided and trimmed. At any stage of the process, various routing specific reports can be generated. These include stock lengths, bend reports and bill of material. The first report being generated is for stock length. Bend report outputs information in various formats for automated bending machines. Route segments are associated to the position or components they are attached to. Segments can also be modified for length, location and orientation. Stock and associated components can be substituted at any time for size and specification. Double-click on a pipe segment and its length can be dynamically changed. Notice the pipe clamp keeps its position relative to the pipe. Transform path moves a single segment, a path of segments or a complete route. Here a single straight segment is being moved and the bends will translate with that segment. Moving a corner will modify its position and the attached segments will update to follow the change. Moving the pipe clamp updates the pipe segments. Other clamps are constrained to prevent unwanted relocation. Where pipe segments are located by geometry, modifying the geometry will update the route. Here the pipe passes through a hole in the frame. Changing the position of the hole will update the route position as well. To modify pipe sizes, Unify Path allows for the substitution of one pipe specification with another. Attached fittings will also update to the new specification. The specification change in this case is from NPS 20 to NPS 32. All fittings, including clamps, will update to the new specification. The next section will continue showing routing methods, placing tubes for fuel and oil lines. The default stock is now changed to a tube of 7.81mm diameter, which is selected through preferences. The default bend treatment is changed from a ratio to a fixed value of 25mm radius. A linear path is drawn parallel to the fitting, with a length defined by selecting a point on the model that it needs to clear. The next segment is drawn from the end fitting using a dynamic axis along the x-axis of the vehicle. It is then connected back into the first segment. The design rule check reports an error, and I will override the error and give a reason for the override. Heel path command is best suited to complete the next route. Select the first and last fitting with the transition method of direct. The last extension will be edited to make it longer to a value of 60mm. In the earlier example, I used transform path to move routing segments. Transform path can also be used to make copies of path segments. I will select the previous complete route and use a motion selection of point to point, and then duplicate the route 3 times. For the next tube, I will use hill path to place the route. Then, to avoid clashes, I will modify the path to suit. The tube clashes with part of the frame. Modifying the last segment length does not do enough to clear the part. Subdividing the long segment 20mm from the end will provide flexibility to manipulate the pipe's shape. Using transform path, the segment will be moved and orientated to clear the frame. Complete the route, the bend treatment for this pipe will be a 15mm radius bend. The existing bends will be replaced and a new bend added. To move the pipe section closer to the frame, a constraint of distance will be used. This can also associate the pipe location with the frame. Dragging an inline filter from the reuse library will add the component to the segment. NX routing supports flexible stock and components. Flexible stock routes hoses and wires. Flexible components allows a single component containing flexible stock to appear in different configurations of the same component throughout assemblies. I will now add two components containing flexible stock. From the library, the hose component is selected. The components are attached to the ports on the fittings connected to the valve. Rotating the hose fittings will set the hoses off in the right direction. The fittings on the other end of the hose are attached and locked to the cylinder with the Move Part command. The hoses now need to pass through the clamps placed in the assembly. Adding extra points into the splined route segment will apply additional flexibility and control. Selecting a route point allows the user to move that point to a location snapping to a port. The remaining point can be moved in free space to modify the shape. Note, pulling too hard on the point moves the other components. The process is repeated to position the upper hose. If bends in the hose are less than the allowed radius, the design rule checker will report the fault. Moving components in the assembly will update the hose shapes. Additional edits are made to refine the route. Even though both components appear to be different shapes in the assembly, they are the same component and would report as 2 off by 1 metre hoses in the bill of materials. The component itself is not modified, the modification is for that assembly instance only. NX routing is fully integrated with all NX design applications. Annex assemblies, clearance analysis, drafting and bill of materials can be applied to routing objects. An example of adding dimensions and bill of materials to a routing drawing.